spent. This is hardly suffering, fearing my own tongue again. Just one song to bring.
Hi, I'm Ashtonay Bastida.
And my name is Amira Brun.
And we will be explaining a problem involving Snell's law. To begin with, we will define Snell's law. Snell's law is a formula used to describe the relationship between the angles of incidence and refraction when referring to light or other waves passing through a boundary between two different isotropic media, such as water, glass, or air.
The symbols used in the Snell's law are N1, theta 1, N2, and theta 2. N1 equals index of refraction of the first medium, which has no units. Theta 1 equals angle of incidence, which is degrees. N2 equals index of refraction of the second medium, no units. Theta 2 equals angle of refraction, degrees. The equation used for Snell's law is N1 sine theta 1 equals N2 sine theta 2.
We would also like to describe refraction. When refraction occurs, the path of light is bent as it crosses the boundary between two media due to refraction. The amount of refraction depends on properties of the media and on the angle at which the light strikes the boundary. Here are a list of media along with their indexes of refraction.
Here we have the diagram representing Snell's law. As you can see in the bold red arrow, we have incidence ray. And the light red arrow is the reflected ray from the incidence ray. The gray arrow is the refracted ray, which can either be bent toward the normal, or away from the normal, or equal to the incidence ray.
The question that we will be solving today is, light travels through a material with an angle of incidence of 50 degrees. If the angle of refraction is 38 degrees, what is the index of refraction for the material?
Step 1. Identify the givens. The givens are theta 1 equaling 50 degrees, theta 2 equaling 38 degrees, the index of refraction for the first, which is an understood 1, and the second index of refraction medium, which is unknown.
Step 2. Draw the diagram and plug in the components. First, we drew the incidence ray, which has an angle of incidence of 50 degrees. Then we drew the index of refraction of the first medium, which has an understood 1 for air. Then we drew the angle of refraction, which is 38 degrees, with the refracted ray. Then we drew the index of refraction of the second medium, which is unknown. This is what we'll be solving for.
Step 3. Plug the numbers into the equation. The equation we have said before is N1 sine theta 1 equals N2 sine theta 2. For N1, we have 1, which is in the given. For sine theta 1, we have 50 degrees, which is right here. Equals N2, which is unknown, and for sine theta 2, we will have 38 degrees plugged in the equation.
Step 4. Solve the equation.
The equation we will have once again is N1 sine theta 1 equals N2 sine theta 2.
We will begin by plugging in the numbers in the equation. Therefore, we will have 1 sine 50 degrees equals N2 sine 38 degrees.
Then we will divide sine 38 on both sides and cross the sine 38 on the right.
After getting the N2 alone, you plug this into your calculator. You will get this answer.
1.24426243 equals N2.
You will then round it to 3 significant figures to get the number 1.24 for the index of refraction of the second medium.
And the answer is
the index of refraction of the second medium equals 1.24. The end.